Hi all, in today's video we're going to be looking at using Maclaurin expansion for more than one expansion today. So we're just going to go straight into an example and show you what a type of question would look like. So for example, we want to expand f of x, which equals e to the negative 2x sine 3x. Okay, so that's the function that we're using. I want to expand this function as far as the x to the power 4 term using expansions for e to the x and sine x. Okay, so some exam questions or example questions don't maybe give you the clue about using expansions for e to the x and sine x in this case. This question actually gives us a wee clue, and that's how you would actually solve this. Now you can see that I've got two functions here. I've got my first function, which is really e to the negative 2x, and that's multiplying sine 3x. Okay, so I've got to do two functions and then eventually merge them together. And that's how you go about doing this. You just treat it one bit at a time to start off with. Now the key thing is, I only need to go up as far as the x power 4 term. So any powers after that, I might write one down to start off with, but I can exclude it later on in my answer, okay? So let's look at the solution. So let's start us off again with e to the x. Now we've seen the expansion for e to the x yesterday, okay, in the previous video. So that becomes 1 plus x squared over 2 plus x cubed over 3 factorial, which is, so that should be 2 factorial I should say, that's what 1 factorial, plus x to the power 4 over 4 factorial, dot dot dot. That's what the exponential one was that we wrote down yesterday, okay, and then we tidied it up. I don't need to go any further because then x to the power 5 would be past that I need to go. So that becomes 1 plus x plus a half x squared plus a sixth x cubed. 4 factorial is 24, so that's a 24 x to the power 4 dot dot dot. Okay, so that's just the e to the x. Okay, now what I'm asked to do is try and expand for e to the negative 2x. Okay, now a way you could do this is you could actually start with that as your original function. So that's your f of x, and you put 0 into it and get your f is 0. Differentiate it, f dash 0, differentiate it again, all that stuff, right? Or you can use the fact that we know what e to the x looks like. The only thing I need to replace the x's with is negative 2x's. Yeah, I can actually just use that there, and I'm actually going to swap it out for negative 2x's here. So therefore the expansion for that would be 1 plus negative 2x. Okay, that x becomes negative 2x, that's the power now, plus a half negative 2x all squared, plus a sixth negative 2x cubed, plus 1 over 24 negative 2x to the power 4. Okay, so that just saves me doing all the awkward differentiations because I know what the x one was. Okay, and obviously if I tidy this up now, okay, the expansion of this becomes 1 minus 2x. Then if I tidy this up, okay, negative 2 squared, that becomes still positive, so it's plus, that becomes 4 divided by 2, that's 2x squared. Then it goes negative, it will be negative 2 cubed is negative 8, 8 over 6 becomes 4 over 3, so 4 over 3x to the power 3, and then plus negative 2 to the power 4 is positive, 2 to the power 4 is 16, 16 divided by 24, you get 2/3. Okay, so that allowed me to just do the e to the negative 2x a lot easier regarding, because I knew what the e to the x was, okay? And that's how I did, even this question doesn't give me a clue, I'd have expanded e to the x first using the Maclaurin's theorem and then just substituted negative 2x into it and then done it that way, okay? So that's the first expansion done. Okay, I'm going to put a wee star next to that to say that that's the first one done. Right, the next one we had to do was sine 3x. That was another function. But again, we can use the fact that I know sine x. Okay, and sine x from yesterday was x over 1 factorial minus x cubed over 3 factorial plus x to the power 5 factorial. Okay, the next one would be negative again. And that's what the expansion was for sine x that we see. Okay, now I know I don't really need the x to the power 5 term because I've already. What did I do? Yeah, she was, yeah. The whole period too. She wasn't late or anything. Alright, thanks. So I know I don't technically need that x to the power 5 term because it asked me just for x to the power 4, but I'm just going to keep it in just now so I can show you what happens if you did have to go further on, okay? So that's my expansion for sine x, okay? So if I take it up, that becomes x minus 1 over 6 x cubed, and then 5 factorial would be 1 over 120 x to the power 5, and so on. Okay. So we want sine 3 of x, so that means what I'm going to do is I'm going to swap out the x's for 3x's. Okay, that's the difference between the sine x and the sine 3x. So that's going to become 3x minus 1 over 6 3x cubed plus 1 over 120 3x to the power 5. Okay, so that's just a quicker way to do sine 3x. It saves me differentiating that function all the time. And again, if I tidy this up and multiply this out, and now I'm going to exclude the x to the power 5 term, okay? Because if I had to work this out, it'd be a bit of a pain, but I know I don't need it because x to the power 4. So I'm just going to focus on these two ones here. So that would give me 3x. Okay, 3 cubed is 27. 27 divided by 6 would be 9 over 2 x cubed. And then it would be plus whatever that one would be, but I don't need the x to the power 5. So, there are my two functions that I needed, okay? I'm going to start this one too. So, if I want to do an expansion for e to the negative 2x sine 3x, okay, I get my expansion for e to the negative 2x, so that's going to be in my first bracket. And that was going to be, again, I'm going to have to include all these terms because it's all up to x to the power 4. 1 minus 2x plus 2x squared minus 4 over 3 x cubed plus 2 over 3 x to the power 4. And you can write dot 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 just to show that there was more terms there. Okay, so that's from the first, that's for e to the negative 2x. And that's going to multiply my sine 3x, which is going to be 3x minus 9 over 2 x cubed dot dot dot. There was more terms there, but the powers would go fast. So now my job is to work out what the expansion would be if I multiplied these out. Now, that may look like a pain, but the good thing is we know we only need to go up to x to the power 4. So anything else that would raise that power, we don't even need to consider. It's not going to be worth it in our expansion, okay? So I would always focus on the smaller bracket, in this case the 3x and the minus 9 over 2x cubed. And I would just take it a turn in each and multiply everything in my first bracket by these, but only consider things that are going to stay power-wise. So if I take the 3x and times this bracket, well, 3x times 1, that's still going to be my power, so 3x times 1 is 3x. 3x times negative 2x, that's going to be negative 6x squared. Still okay. 3x times positive 2x squared, that's going to be plus 6x cubed. 3x times negative 4 over 3x cubed, okay, so therefore that's going to take me to x power 4, that'll be the last one this will work for. The 3's will cancel, so negative 4 x to the power 4. And you can see the last term for 3x times in would be 2/3 x to the power 4. That'd take me to x power 5, but it's past it, I don't care about it. Okay, so that's me dealt with the 3x bit. Now I need to times negative 9 over 2x cubed by things in the first bracket, but again, only consider things that's going to keep it x to the power 4 or lower. So the negative 9 over 2x cubed will times the 1, that's going to give me negative 9 over 2x cubed. And then negative 9 over 2x cubed, that can times the negative 2x, so that's going to become plus, the 2's will cancel, plus 9x to the power 4. And then anything else I times 9 over 2x cubed by, starting with the first one, 2x squared, it's going to take me to x power 5 and onwards. Okay, it's passed, so that's me done. Okay, so I can write, okay, it's more, okay, just to say that there's more terms there, but that's all I need to consider. And now it's just about tidying up your terms. Okay, so there's my only x term there, 3x. If I look at my squares, well, it's only negative 6x squared that I've got. If I look at my cubes, I've got 6x cubed minus 9 over 2x cubed. So if you combine them, you would get plus 3 over 2x cubed. And negative 4x to the power 4 plus 9x to the power 4 is plus 5x to the power 4. Okay, so you're just multiplying out the brackets, but you're only writing down things that keep you within that power. Are we okay with that example? Okay.